Describe and explain the relationship between surface area to volume ratio and human body and metabolic rate. Okay, so we have a small person, a bit like myself, and we have a large person. The smaller the person is, the larger the surface area to volume ratio would be. The bigger someone is, the smaller the surface area to volume ratio is going to be. Smaller things have a big surface area to volume ratio, therefore they lose heat, a bit like a mouse. Lose less heat the larger you are. Now, in order to maintain your body temperature, you are going to have to respire. So theoretically, if you are small and have a larger surface area to volume ratio, you'll do a slightly higher rate of respiration in order to maintain body temperature. That's what this question is all about. They're saying the surface area to volume ratio increases and metabolic rate increases. Metabolic rate is just a more biological term to relate to respiration. So the larger the surface area, the larger the metabolic rate will be. The reason being is because, mark point 2, if you have a big surface area to volume ratio, you will lose more heat, or you will lose heat faster. I want to do a higher rate of metabolism or respiration to release the heat, replace the heat, or maintain my body temperature. There is a big reject on the idea of producing heat. That's not allowed because we can't do that physically. On to a maths one then. It looks complicated, but it isn't as bad as it seems. The copy over has missed off that square root. So we've got person A and we've got person B, and ultimately we want to know the surface area to volume ratio, and that too is very important because it indicates where our ratio should be. So first up, if I was working out surface area for person number 1, I would do square root of 181 times 90.9 divided by 3,600. So my surface area for person 1 was 2.14. My volume for person 1 is 90.9 divided by 1,010 to give me a volume of 0.09. Now, if I was to put this into surface area to volume in a ratio, whatever is on the right-hand side always needs to be by the value of 1. So what am I going to do to 0.09 to turn it into 1? Well, I'm going to divide it by itself. And whatever I divide on the right-hand side, I've got to divide on the left-hand side. So 23.7 to 1 is what I would get for person A. My gut is telling me that person A, because they have a bigger height and a bigger mass, they are going to have the smaller surface area to volume ratio. So my gut is telling me person A. But just to make sure, I'm going to do the calculation for person B as well. So for surface area, I'm going to do the square root 149 times 62.62 divided by my 3,600. That gives me a surface area of 1.61. My volume would be 62.62 divided by 1,010 to give me a volume of 0.062. Same principle applies. If I'm doing surface area to volume, 0.062 is going to be on the right. Surface area will be 1.61. I want to make it a whole number, so I'm going to divide by itself. So 0.062 divided by itself. And if I do that on the right-hand side, I've got to do it on the left-hand side as well. That gives me a surface area to volume ratio, technically, of 95.7 to 1. However, as the question says, I need to be working in 3 significant figures. Therefore, it should be 26.0 to 1. Who has the smaller surface area to volume ratio? A does. There are a lot of little kind of marks for numbers that you've calculated here and there, so you've got to check it carefully. There's a big error in 0.7.3, so everyone got 1 mark. Yay. And name 2 structural features of the gills of the fish that increase the surface area: lamella and filaments. If you didn't know them, you didn't know them. It was a recall question.